Moving on, example 4. This is a very big question, so let's have a look. First, diameter EB. Diameter, I know this is diameter, great. I do not have any angles that's clearly facing it that's going to be a 90 degree, so I'm just going to keep in mind that I do have some semicircles. Tangent, I have the tangent TS and the DS. Great. Next, arc BC is 52 degrees. 52 degrees. Arc DE is 48 degrees. Ooh, that just gave me some more information. If that is 52 degrees, and I do have the DE as 48, and this is a semicircle, I could easily find out my arc CD is going to be 180 minus 52 minus 48. So 180 minus 100, that is going to be 80 degrees for arc CD. Next, I would need, well, I'm given AB is 28 degrees. Great, if AB is 28 degrees, and we also know AF is 134 degrees, this is the other half of the semicircle. I can easily find out about arc EF. 180 minus 28 minus 134 degrees. That's going to give us a 28 degrees, or actually 18 degrees. For EF, now it's asking you to find all the numbered angles. Well, let's go one by one. Angle 1. Angle 1 is facing the arc of DE, so it's going to be half of arc DE, so it's going to be 24 degrees. Next, angle 2. Angle 2 is right here. Angle 2 is facing arc DF. Arc DF. DF is clearly going to be DE and EF together, so that's going to be together 66 degrees. Half of that is 33 degrees. 33 degrees. Next, angle 3. Angle 3 is facing the arc AB, so it's going to be half of arc AB. AB is 28 degrees, so that is going to be 14 degrees. Next, 4. Angle 4. Angle 4 is right here. Well, that looks like a bit tricky, so I'm actually going to leave that for now. So I'm also going to change color to show you guys I haven't found that one yet. Because I don't have anything that is facing. It looks like it's inside some kind of triangle, so I'm going to deal with that in a bit. Next, angle 5. Angle 5 is right here. And it is using the center, so that's actually just a central angle. So it's the same as the arc EF, which is 18 degrees. Next, angle 6. This is 18 degrees. Angle 6. You have two different ways to find out about angle 6. First, angle 6 and its vertical angle is facing arc AB and DE. So I could do half of AB and DE. And that is going to give you half of 28 plus 48, so half of 76, which is 38 degrees. That's one way. Or we have a 24 degree here, we have a 14 degree here. You can find about this angle, because that is going to be inside a triangle, and then use 180 to minus that angle. That would also give you 38 degrees for 6. Moving on, 7. Angle 7 is actually outside the circle right here, and the arc is forming is AB and DF. So that will be half of DF minus AB, which means DF is 48 and 18 together, 66. So 66 minus 28 is going to be 38. That is half of 38, which is 19 degrees. Next, we are moving on to angle 8. Angle 8 is facing the, it's forming the arc BC and the arc CD. So it's going to be a half of arc CD minus arc BC. CD is 80, BC is 52. 80 minus 52, that is 28, half of that, 14 degrees. Next, angle 9. Angle 9 is right here, and that is not quite clear. I'm actually going to change the color so you can see a bit clearer. Angle 9 is right here. It's being formed by a chord and a tangent line. So that means I'm going to need half of the arc that's included in that angle. So it's going to be arc BD. So half of arc BD. That's 52 degrees and 80 degrees, together 132 degrees. So that angle is going to be 66 degrees. And now, if I already know about 66 degree right here, I also know about angle 3 being 14 degree. I can easily find about angle 10. That is 180 minus 66 minus 14, and that is 100 degrees. So that's one way to find it. Or another way is you can choose to use this arc AD and then do half of it. That works as well. Next, angle 11. 11 is about a little bit tricky as well, because you do need to see angle 11 are two tangent lines. So you do have this little arc CD right here, and you have the bigger major arc on the other side. So that is going to be half of arc. Let's just use any letter, CAD minus arc CD. If CD is 80, then the other part will be 280. 280 minus 80 is 200. So that means my angle 11 is going to be 100 degrees. That is, let me write it down. That is 100 degrees. Okay, moving on. Do we have an angle 12 somewhere? Actually, we don't. We already found 10 to be 100 degrees. 11 is 100 degrees, and that's almost everything. Now we just have angle 4. Let's look at angle 4. Angle 4 is the specialist thing here, because there's nothing specific that is facing. It is just inside right here, a quadrilateral. So there's kind of no other ways to find that except finding the quadrilateral. So we are going to use 360 degrees minus the 33 degrees. And again, you can find this little question mark because these two add up to 38 degrees. So the other part of the whole triangle would be 142 degrees, which is right here, 142 degrees. Another angle you would be able to find is this angle right here, because this little 5 is 18. That leaves the rest to be 162 degrees. So we are just using 360 minus all of these angles. And again, this angle, you can also use angle 6 to find it. 180 minus 38, that is 142. So altogether, that is 360 degrees minus that's 304, 337 degrees. That leaves number 4, angle 4, to be 23 degrees. So that's about the most complicated example so far. But as you can see, I am just going over each angle at a time. And of course, when I'm labeling information that's given in the question, I am going a bit extra to combine some information to label all the arcs. Because if you know every single arc, all the angles, most of the angles would be easily identifiable related to some kind of arc in the circle. So that is example 4, and that is everything for 6.3c. Thank you.